Novotech was founded under EDD, also known as the CARPA initiative, where students are given opportunities to try and further and gain perspective on their future career fields. CARPA tries to push our limits and try to see how far we'll go to extend ourselves to finish Project Thunderbird.
The purpose of the Project Thunderbird Challenge is to further develop autonomous and rugged robotics. The robot has to be able to enter the volcano, survive the inhospitable environment, while also collecting data. So, the robot must be able to bore its own tunnel into the volcano, enter the volcano, survive things such as landslides and other possibilities for inside the volcano, and also collect a sample from the magma inside of the volcano. So, upon reaching a temperature inside the volcano that is inoperable for the robot must enact a separation sequence, which it releases a separate robot or drone which carries our data to an outside source.
The first step to approaching this relatively large problem is to break it down into several pieces and to brainstorm ideas for each session. How we approached that was to utilize all of the team's resources, including our interns, the various members of our team with special areas of expertise, and to come up with solutions, multiple solutions for not only every part of the problem, but also to try to fit them together into a part of a larger whole. Especially if we're gonna make a non-rigid outer covering in terms of fabric or sheets, it's gonna be split into a support structure, which is gonna be a
3D modeling is important because it helps us conceptualize what we're going to be making better than a sketch can. It helps us in learning what we can do with the materials that we are going to use, and we also need to be able to test them. And really the only way we can test them before we have the actual materials is using the programs inside of 3D modeling programs that we have, like Inventor, so that we can stress test them and test different configurations and also assemblies.
In both the manufacturing of the final device and the prototype, our team utilized a variety of tools. One of these tools was the Versa laser, which we used to make many of the prototype parts and engrave the final, and it gave us access to great efficiency and repeated manufacturing of different versions of the same part.
Prototype is critical because prior to this phase, all we have to rely on are theoretical estimations. And even though these do provide us a general idea as to whether our product will work, they're by no means a guarantee. Prototypes provide us physical proof on whether or not our product will work. And by testing, we can see whether our product fulfills our performance standards, and we can determine what areas actually need improvement.
A lot of the designs that we had to make had to be redesigned because of both manufacturing as well as buying it. That was especially present in the tracks and making those because one of the decisions that we made was to actually go and find a company that could make the track for us, but because it was too expensive, we had to change it to a different design. That was also present in the frame because we had a triangular frame beforehand, but making the amount of passes and everything would be difficult for manufacturing as well as time efficiency, so we changed it to a parallelogram frame.
So when we were initially posed with Project Thunderbird, we had to choose a few key constraints that we would base most of our design off of, and it just made it as a general guideline for our different design groups in working upon the project or the robot itself. The robot itself is based on a tank design from World War I, which is a parallelogram, really. We decided to go with this in the end because for the angle of attacks that we'd have to face in cresting small objects within the caldera, this seemed to work. We were able to build a lot of structure through some key support pieces. One of those being the wire box that we collectively call it. It's a piece that houses most of our PCB and our main processing computer. It protects it while giving structure to the rest of the robot, which we found to be a very nice piece due to its dual functionality. Our hatch was based off of a design concept that we presented early in brainstorming, which was the idea of a disaster-proof house. So the hatch is more of a moving roof, really. It remains a very rigid piece, but when we need it to, it can open up for our escape system or escape vehicle to leave the device carrying our information.
So here at Novatech, through our brainstorming and engineering process, we came up and were successfully in flying the first multirotor in EDD history. That said, it wasn't easy. We went through many brainstorming designs until finally coming up with our first prototype, a X-style quad with the front two rotors lower than the rear two. However, while this design flew great and was the first thing to fly in EDD, it was too big, so we went smaller with a tricopter, which was unfortunately less stable, so we did have to scrap that idea. And finally we come to this final design, which takes the stepped motor design of the first prototype and takes it from an X-style quad where you have two motors in the back, front, and then two in the back, to one in front, one back, one left, one right. And we raised it up so it can be stable, powerful, while having enough room to fit all of our electronics.
Some challenges and hardships that we face as Nova Technologies is that we have to fund our own project and find sponsors that are willing to support us and our goals. And the issue with that is most companies and people see us as just a high school class that needs to complete a project, when really we are a real company where we have our own company image, our own branding, our own slogan, our own employees that have specific tasks and jobs that they need to get done. So we need to convince some companies that we are this real company trying to complete a real engineering goal. And we do have some sponsors that were willing to support us, and that includes the Toyota Motor Corporation, the Kiwanis Club of Gardena Valley, and our high school parent-teacher student organization. And without them, we would not have been able to complete our goals, and they have significantly helped us.
So this past year, Novatech has seen a lot of ups and downs. A lot of this can be attributed to our team dynamic. We are a team of many intelligent individuals, and oftentimes that results to a clash of heads. One person will have one idea, another person will think they'll have something better, and no one can really come to an agreement on that. The way that we resolve this issue is we would have a lot of team discussion, we'd have a lot of brainstorming to see which idea is better, which one is viable, which one we should go with, and that's how a lot of our disputes have been resolved. And generally over the course of this past year, we've seen moderate success with this.
So first, being named leader of a company was cool. I didn't really know how to lead a team at the very beginning. It was pretty difficult trying to motivate 21 students. Hopefully from all these things that have happened to me throughout the experience of being a leader, from extending to having a conflict issue or a or haven't been drawn back on the schedule because something happened, I've learned to manipulate the time that we have to where we try to focus not only on the drawbacks but also on the parts that we can further build on, to where if it's either building trust with our teammates, or it's changing the way students look at engineering, how they focus on solving problems and motivating every peer that we have. I have learned that motivating a student is not as easy as it is. You have to learn how each student revolves around the field. So every student has a perspective on how a company should run. And me as a leader, I've learned that I have to take everybody's personal judgments into account and being able to work with them. And whenever they have a problem, listen to them and talk to the team as a whole. And I've learned to get a deeper personal experience with every student and connect to them on a deeper level. And I hope to build upon that in the future. So, yeah.
Along with the title of being Deputy Project Manager, or DPM, I learned that scheduling and creating a timeline was one of the most important duties of a leader. So previously, I've usually been known as being a designer, or someone who contributes directly into the technical aspects of engineering. But over the past 2 semesters, I've learned that creating a timeline or creating deadlines is the key job of leader, and that goes into any job title or any leadership position.
EDD has made me a better manager. I know how to manage time better, especially both my time and my team's time. I also know how to handle people better. It gives you an interesting perspective on every single team member and as well as the team as a whole. You kind of figure out like when people want to work and when they don't, and how well they work together in unison.
So for my role as chief scientist, I found that the inner functionality of all of the systems of the robot has been really important to maintain, because there are certain things that one subsystem like electrical could not complete without design being on the same page. So keeping everything within perspective has been very invaluable for me to learn this year, and I hope to take that on with me when I go to work for a small engineering company, because having the mindset of trying to make sure not tunnel visioning on one part that will work, but making sure, looking at the bigger picture to make sure everything works.
So I joined EDD with the mindset that this would be a challenge. No one wants to go through high school without actually doing something. I felt like I was just going through the motions. I was doing what every other high school student was doing in the nation. I wanted to do something that set me apart, something that would challenge me and cause me to think in a way that maybe I haven't thought of in the past. Really, I just wanted an experience. I wanted something to push me, and EDD was something that did that. It's made me think in ways I never thought I could. It's given me challenges, such as being in a team setting. It's been very different, but it's been a very enjoyable experience.
EDD has taught me how to work with others. It's taught me what I will expect during my EDD year. Novatech, being with these students, seniors, has taught me that your partner or your friend will depend on you and you will depend on him. And there is no team stronger than a bond when you're together. But if you're working by yourself or you think you're better than others, then you won't get very far. When I want to become PM during my senior year, and from what I learned here is that you must connect with your colleagues or connect with your members and be able to talk to them, translate their ideas, able to vision, have a picture in your head what your robot or what your project might look like. I'm very happy they allowed me to intern. It has taught me a lot, especially how to work together, work with other people, or what to expect when stress comes in or pressure, how to understand when you're in a tight situation. Do you just sit down and think, or do you come together, brainstorm, or do you take a break? When to take a break, when to relax.